Well, I think we have waited a couple of minutes so we can start. So welcome everyone, and thank you for joining us to this webinar. The webinar is called the new EU U-space regulatory framework, and it's challenge to urban air mobility, and is organized by ITG with the kind help of ENAIRE. Please, the webinar is scheduled around 1 hour and 20 minutes, including the question and answer section. We will try to be as more efficient as possible, just to have plenty of room to discuss at the end of the session. Please keep your microphone mute and your camera off at any time to ensure that the connection is good for everyone. Also, you can submit your question via the GoToWebinar chat at any moment. We will be more than happy to answer that at the end of the session, and if not, we will try to answer after the session privately. Then the event will be recorded, and the recording will be shared with all of you together with the slides. And also after the webinar, you can contact us via the email address that you can see at the bottom of this slide. So please send us your question and feedback. It's more than welcome. The agenda for today will be a short introduction where we are right now, followed by a presentation by Raquel Moldes from ENAIRE, titled The New U-Space Regulatory Framework. After that, Eduardo Garcia will continue with the U-space scenario in Spain. Then we will slightly change the topic and focus on urban air mobility. The first presentation will be carried out by myself. It will be called Operational UAM Challenges. And then my colleague from ITG, Daniel Gutierrez, will continue with the Safety UAM Challenges. We will closure the session with a question and answer colloquium. So thank you, I hope you enjoy. And now, what is ATM-What 3D? ATM-What 3D is a project promoted by the Ministry of Science, Innovation and Universities in Spain, and by 4 top technological centers. As you can see the names below is Fadakatech, ITG, AISIA, and NITEC. We have extensive experience in intelligent unmanned systems and complementary capacities to ensure a succeed in the development of this project. And the objective of the project, what is important, is to develop advanced technologies and functionalities and provide disruptive solutions to urban air mobility. And who we are? Well, as I said at the beginning, the webinar is organized by the ITG Galician Institute of Technology with the kind support of ENAIRE. In our case, Enrique Ventas and Daniel Gutierrez will be the presenters on behalf of ITG Galician Institute of Technology, which is a privately funded national technological center with over 70 highly skilled professionals focused on several areas. In particular, and relevant for this webinar, we are very focused on UAS and U-space. And on the other hand, we have ENAIRE, who is the leading air navigation aeronautical information service provider of Spain. And they provide en route, approach, and aerodrome ATC services, as well as flight information alert consulting services over a territory of 2.19 nautical miles square kilometers. And now, just a reflection about why is this webinar so important. First, because as you know, there's thousands of drones and air taxis will be flying in our cities sooner than we think. And this is very important, and we need to organize that traffic. And that's the reason because U-space is so important. For those of you that don't know what is U-space, U-space is, so I think that someone has a problem with the audio. Sorry, Walter, can you say what is this something about the sound? Does anyone have the same problem? Okay, perfect. I think it's all good. Perfect, thank you. So let's continue. So U-space is more than an airspace. U-space is a set of services and procedures that will allow drones to operate safely and efficiently in the airspace. All these services will be delivered following different stages that you will see later during the presentation. It's called U1, U2, U3, and U4, and will go from minor complexity to major complexity, and will be deployed over the following decade. And this deployment will be key to enable urban air mobility and to comply with the challenging sustainability goals promoted by the European Commission. Also, it's quite important that we consider always that safety is going to be the priority, safety first. But however, new technology brings new challenges, and these new challenges will be seen during the presentation. So thank you very much. Now I don't want to delay more this presentation, so I give the floor to the first presenter, Raquel Moldes. So thank you very much and enjoy.
Thank you very much. First of all, we want to thank ITG for the opportunity of participating in this webinar. And I'm Raquel Moldes, and I'm here today to talk about the new U.S. space regulatory framework. Next slide, please. Okay. In order to harmonize the implementation of U.S. space in Europe, EASA launched 1 year ago, in March 2020, its EASA opinion on the regulatory framework on U.S. space, which was recently approved last February by the EASA committee, and will be applicable from January 2023. This regulatory framework sets out provisions for US operators, US space service providers, and providers of common information services, and are exempted to apply this regulation state operators, model craft, small aircraft below 250 grams, and IFR flights. And the member states will be the ones who designate geographical zones as US space airspace. Next slide, please. This regulatory framework sets 4 services as mandatory and necessary. These ones are the Network Identification Service, which provides the operator ID and locates the UAS geographically. Also, the Geo-Awareness Service, which provides dynamic limitations and restrictions from the US space airspace. The Traffic Information Service, which alerts US space operators from other UAS flying around them. And the UAS Flight Authorization Service, which ensures that these flights do not conflict with other authorizations in the same US space airspace. Additionally, it has set 2 other services as optional: Weather Information Service and Conformance Monitoring Service, which provide information to the US operation on deviations from the planned flight. And these 2 services may be designated as mandatory for certain US space airspace based by the state or the competent authority based on a risk assessment. Next slide, please. The regulation also defines the common information services, and the information included within these services are the geographical limits of the designated US space airspace, performance requirements which are set based on the risk assessment, a list of certified USSPs, UAS geographical zones relevant to the U-space airspace, and static and dynamic constraints of the U-space airspace. This information is provided by the competent authority. Also, the NSPs provide common information regarding the dynamic reconfiguration of the airspace, providing restrictions on the airspace, U-space airspace, and also leave operational data, which is relevant for the aircraft flying in the U-space airspace. And finally, the USSPs provides terms and conditions of the U-space services. All this common information can be provided by a single common information service provider designated by the member state. And in such case, the single common information service provider will gather all this information and make it available to all operational stakeholders. Next slide, please. This singularity of having the flexibility to have a single common information service provider or receiving this common information from the different actors allows for two different U-space architectures. The distributed one with the common information provided by the competent authority, ANSPs and USSPs, and all USSPs in exchanging information among themselves, or a centralized architecture with a single common information service provider, which acts as a single trustworthy repository of all this information and establishing a link between the common information and the U-space service providers. In Spain, we advocate for this centralized architecture, as we believe that it simplifies the implementation of the whole system and reduces the workload for the different actors. And also sets clearly the responsibilities, accountabilities, and liabilities of all the involved actors in the U-space. Next slide, please. Finally, this regulatory framework also provides set provisions for ANSPs and manned aviation, but these provisions are set by amendments to existing regulations. In the case of the ANSPs, these provisions are translated in the regulation 373 and says that ANSPs are responsible for segregating manned aviation in controlled airspace through dynamic reconfiguration of the airspace. These dynamic reconfigurations sets a limitation or restrictions of U-space airspace based on the needs from the ANSP to allow a manned aircraft in control U-space airspace to go through it and segregate this aircraft from other UAS flying in U-space airspace. And the provisions for manned aviation are set in regulation 923, and it says that all manned aircraft that do not receive ATC service, so they are flying non-controlled airspace, shall make themselves electronically conspicuous to USSPs providing services in such U-space airspace. this is my last slide and provides a overall view from the U-space regulation.
Thank you very much, Raquel, for this comprehensive presentation. I think it's very important that finally we have a basic regulation regarding U-space and will allow us to continue growing. So thank you very much. And I think now is the moment to see how this regulation might be applied in different countries, for example, in the case of Spain. So welcome to our next presenter, Eduardo Garcia. The floor is yours.
Good morning, everybody. Thank you for attending this webinar organized by ITE. Thank you, Enrique, for your presentation and hosting. Thank you also to my colleague Raquel, who has done a very good introduction about the U-space regulation. Now that we have seen an introduction to this regulation, the next question to pose is, which are the next steps? Is the U-space scenario here in Spain? Well, first of all, I'd like to talk about where do we start from the building blocks. In Spain, I would consider two building blocks for U-space from an ENAIRE point of view. The first one is ENAIRE drawings. Here you can see a screenshot of it. It has been the first attempt successful to create a geo-awareness tool for drone pilots. It works as a web tool and also as an APP. And from here you can see the airspace structures that affect your flight, no matter if you're flying as a hobbyist or as a professional drone pilot. Next slide, please. The next building block is Planea. This tool has been developed recently. It was released in 2020. And this is a tool that digitalizes all the workflow regarding the coordination of drone operations with ENAIRE. Before this tool was developed, this type of coordinations were quite annoying for the operators, as they had to coordinate by themselves with each board involved, and do all this via email. And now, this workflow is centralized through this tool. You can see the progress of your coordination request and interact with each ENAIRE department with this tool. This way, the process is much more ordered, smoother, and error-proof, no emails lost. It helps to reduce the time of coordinations. Next slide, please, Enrique. And this is a quite important slide. The reason that motivated the development of Planea. In this slide, you can see how, over the past 2 years, the number of coordination requests from drone operators has been consistently increasing month by month. This made it necessary to digitalize this kind of request. As you can see, the upper line in color blue represents the total. We don't need to go into the different categories of coordination. As you can see in the right side of the slide, the total number of coordination requests nearly doubled from 18 to 19 and tripled from 19 to 20. The data shows that the tendency has already got exponential. The Spanish drone sector is taking off. Next slide, please, Enrique. Now that we have seen the building blocks, which is the background? Well, for us, for ENAIRE, as many of you know, our U-space background is DOMUS. CESAR funding project, DOMUS was conformed as a consortium of 17 companies, all of them listed in this slide. In a very tight schedule, built up a complete U-space system, providing services ranging from U1 to U3 level. It was a BLD in 3 different locations: Ankara in the north of Spain, Atlas premises, and Villa Carrillo city center in the south of Spain. Up to 5 drones flying at the same time in these 3 different locations, and all this was showed in live in a public demonstration with the presence of State Secretary of Transport, Mr. Saura. Behind all this, DOMUS was a demonstrator that showed that multiple U-space service providers could provide services in the same airspace at the same time under the coordination of a central entity. And what did we learn from those? Please, next slide, please. What we learned is that a centralized architecture let us build this kind of system with the present technology. The technology that is mature enough to deploy at this time all these necessary services. The centralized architectures are very promising and interesting from the engineering point of view, but not mature enough for the present time. Here in this slide, we can see a classical scheme of the Domus architecture. As a summary, it was conformed by the ecosystem manager, the central entity that performed the particular task, its tactical protection, and provided the masks to the system. USP were the U-space service providers for the drone operators. You can see also the ATM system that was interfaced to the ecosystem manager, and also the authorities that had access to U-space system as privileged users. And most important, all of these worked. So, well, now we have seen the building blocks, the electronics, and the Domus, which are the next steps. Next slide, please. Well, the next steps, the present, is the announcement of the ENAIRE U-space platform. ENAIRE is going to launch at the beginning of next year its own U-space platform, and it's going to develop it based in experience gathered in Domus. That's the reason why I used the same architecture scheme on the previous slide. It's going to be in two phases. In the first one, that we hope to be operational in January next year, it's going to be a monolithic system, being at the same time, let's say, this and USP all together. The purpose of this phase is to gain experience, gather data, knowledge, and polish the second phase. Next slide, please, Enrique. And the second phase, as you can see in this slide, deployed from January 2023 onwards to be compliant with EASA U-space regulation. In this phase, the platform will be split into two different entities, the phase and USP, which will have all public USP in parallel to any other USP. And with this, we hope to boost the takeoff of the drone sector in Spain that we've seen in the previous slide. We think it's the best way we can support it. More variety and more complex operations will be able to take place. There's a lot of work to do, but we have enough energy. This is the illusion that we have in our team to get this platform deployed at the beginning of next year. A lot of effort, but we hope it will be worth it. Next slide, please, Enrique. And what is the future beyond, despite all of this that we've been talking about? Well, urban air mobility. As we know, CESAR ambitions 4 levels of U-space: U1, U2, U3, and U4. U4, the advanced services, are supposed to support the most demanding services: passenger drones and partial drone delivery in very complex environments, let's say urban environments. For this purpose, we are already working in BLD in urban air mobility through CESAR joint undertaking projects. As you can see here, Chorus, which will perform demonstrations in Castelldefels, Barcelona. They will be drone parcels delivered. Angular, which will perform demonstrations in Santiago. And also U-space or UAM, which will perform demonstrations in Villacarril and Jaén. And this is all, just to have an outlook of the U-space scenario here in Spain. Thank you, Enrique, and I give the floor back to you.
Thank you very much for the presentation. I think it's quite important to see how U-space will be delivered in the different countries, because at the end the regulation is just the basic regulation and different solutions can arise in different places. So now let's going to change a little bit the topic and let's focus on UAM challenges. First, and I think it's what is very important, is to define what is urban air mobility. The first thing is you go to Google and type urban air mobility, you are going to find maybe a Wikipedia definition. We all have to admit that have visited Wikipedia to check the definitions, but it is not the best place to do so. Because, for example, if we go to this one, we see that the urban air mobility refers to urban transportation systems that move people by air. Well, this definition is fine, actually, but it's not fully complete. Because if we go to the NASA definition, for example, the NASA vision, we can see that UAM is a safe and efficient air transportation system. So far, it's very similar to the previous one, but the difference here is because where everything from small package delivery drones to passenger carrying air taxis operate above populated areas. And this is key because we are not talking about just moving people from one point to another. We are talking about all type of operations. And in the picture that you can see at the right, there is one element that it is not a drone because urban air mobility was here before drones. You can see an helicopter that has been supporting people moving from one place to another, supporting emergencies, supporting everything, and will continue with us for a long time. So just to have an overview of the different operations that we can have in a city, we can have, for example, inspection. We can have the helicopter doing an emergency or just a surveillance. We can have delivery drones, medical assistance with drones, and also the air taxis, where you can see at the bottom of the page, of the slide. But why do we need something new to manage this traffic in your cities? If we take the definition of ATM, air traffic management, by ICAO, that we can see is that the management of air traffic and airspace can be done through the facilities and seamless services in collaboration with parties. So this is very important because at the end, if you read that, you can see that you can manage drones easily. At the end, there is nothing specific about aircraft in that definition. However, if we go to the definition of U-space and taking into account what my colleague Eduardo said before about the exponential growing of the drones operations, we see that there is two key factors. First, digitalization and automation, and the second one is that U-space will be able to manage a large number of drones. So saying that, let's go in just to check what are the main difference about ATM today and U-space UAM. First, we can check the flight level because right now ATM is only managing flight level above 500 feet or 1,000 feet, depending on the scenario. And however, the U-space will manage flight levels considered very low level. That it can be said that it's below 500 feet, but nevertheless, it depends on the city and the size of the buildings. Because at the end, you need to give a buffer between the buildings and the different vehicles. Then another thing that is very important is the traffic volume. Right now in ATM, we have two different types of limits. First, the airspace configuration, but also the human capacity to manage this traffic. At the end, right now, we are managing limited operation because of that. And this will be totally different in U-space because we will have thousands of simultaneous operations, which at the end will require additional automation. Then we have another difference that is key is the operation type. At the end, in ATM, we all know what is the operation. You depart from one airport, flight trying to follow the best route possible, the most efficient route, and then at the end you land in another airport. Of course, there are other differences if you talk about helicopter or other manned aircraft, but at the end, all the possibilities are well known and very limited. However, the limits are to be discovered in U-space. We don't know what are going to be the business cases. We don't know what are going to be the operation, and this is quite important to define the challenges. And then there are another two key aspects very related between them, the control and the digitalization. First, the control. Right now it's very human-centered, ATM, so it's very manual or in some cases semi-automated operations. So semi-automated control and monitoring. And this is going to be totally different in U-space, where at the beginning, yes, will be semi-automated because technology is not prepared, but in the future will be fully automated. And then digitalization. Right now in ATM, what we see is that communication are analogical. You can see this because the controller needs to contact most of the times with the aircraft via radio. Yes, this is changing. This is going to be an evolution. For example, we have the CPDLC that allow clearance at the airport and another message exchange during the flight. But the point is that in U-space, all communications will be done digitally. Of course, maybe there are some emergencies where you need to take your smartphone or radio to call another one, but the objective is that everything is automated. So with this introduction, where we are now in U-space. Right now, as you can see in the image, we are just giving our first steps to be able to catch the drone, to be able to have the drone in our operation. First, right now we have a limited number of flights. Most of the operations are done in visual line of sight, VLOS. Also, the infrastructure is almost non-existent. When I say infrastructure, is dedicated infrastructure to drone operations. It's under development, and there is some news that will be in the coming years, but right now it's not available. And also, thank you to the latest regulation, now we have a basic framework with regulation and some standards, but just for the basic services of U-space. Then in the next decade, we can move to a jogging stage, for saying it that way, and we will have a growing number of flights every day in our cities. Also, the new technology developments and the regulatory framework will allow beyond visual line of sight operation and the first VTOLs or air taxis. Also, there will be a continuous infrastructure development, and I say in the previous part, and this will be key to facilitate the operation. And also, the regulation and standard will continue the work done, so there will be a solid regulation and standard in the coming years. But the full speed of deployment, the sprint, will be done beyond 2030. And in this case, the forecasts say that around 7 million laser drones will fly more or less around 2050, and also over 400,000 commercial drones will operate in our skies. Additionally, there will be all kinds of operations with minimum restriction just for safety reasons. Also, there will be a dedicated infrastructure for drones and a full regulatory framework, and I think dozens of standards available to ensure interoperability between the systems. But to get all of that, we need to go through different challenges. And I just include here some of the challenges that we note and are being addressed in different projects. The first one, and I think it's obvious, are the obstacles. At the end, you are flying within a city and you have the buildings and other obstacles. You have permanent obstacles, buildings, for example, but you also can have temporal obstacles. For example, you can have a work, you can have constructions, you can have any other event that can interfere with the operation. But obstacles can also lead to additional challenges. For example, interference. At the end, you are moving in a city, the communications are higher here. You have more people trying to communicate, more systems trying to communicate between them, and at the end, this is going to generate different issues. But not only that, at the end, you can lose this connection. You can have communication and GNS occlusions that will jeopardize the operation. But also, there is one particular effect that the obstacle can bring that is called urban canyons. At the end, if you imagine, for example, the Colorado Canyon in the United States, you see a road in the middle of buildings. And this is going to increase the interferences, and this is going to generate additional weather events called micro weather events. That will be another thing. And this will generate strong winds, this will generate turbulences, and at the end, this will affect the performance of the different vehicles. Apart from all the obstacles and all the problems associated to them, we have another two, very important, is the lack of infrastructure. As I said before, it's very important to have this infrastructure. And just to put you a simple and very clear example is when I was preparing this slide, I tried to find an icon to put there in the lack of ground infrastructure, and I was not able to find something related to drones or drone port or vertiport or something similar. So finally, I had to use a flight landing. And this is one of the samples because we need to develop this, and this is going to be a challenge, but I'm pretty sure that we will be able to achieve that. And similar to the communication, navigation, and surveillance CNS infrastructure, that will be also key to be able to connect with the different drones. Then all of this will enable a coordination of simultaneous UAVs operation. But not only that, as I said before, manned vehicles such as helicopters will continue to be here. So we also will have to coordinate with manned traffic. And for that is key to have a proper airspace structure with a governance layer. Right now, there are several studies, there are several projects investigating how should be the best airspace structure, but in my opinion, it will depend on the city, it will depend on the collaboration reach and the service provided. You can, for example, use corridors. You can use a distribution by layers, providing buffer between layers to ensure safe operation, but you can also provide free route, similar to the traditional aviation, allowing vehicles to move from one place to another and coordinate between them to avoid conflicts. But all of this is only possible if we continue improving the UAV's performance. At the end, you need to take into account the speed, you need to take into account the site, and they need to be able to provide coordinated information with all stakeholders. So this is very important. We will be able to differentiate between maybe high performance vehicles and standard performance vehicles to put in one layer or another one, but this will be the future. And the last, but I think most important thing is we need to gain public acceptance. And this is going to be very important, and all these challenges need to be addressed to ensure that people are comfortable with drone operation. And if people are not confident about operation, the main issue can be that in the future they don't want that drones are flying over their heads. So it's very important that we address all these issues and be able to reach their expectations. And just to finish and leave the floor to my colleague, right now there's a road to the future. It's very important that the integration of U-space right now is on an early stage, but will be deployed faster than we think, but there is a long road then. And for that is key to continue the research and demonstration of technology. For that, I think it's crucial, it's essential to continue the work done in National EU Horizon 2020 research and demonstration initiative. For example, in the case of IMOV 3D as a national project, or for example, if we take into account European project, for example, the case of AMULET, CORSUAM, or U-space for UAM. And just to give you an overview of what these projects are doing, I will focus on AMULET because both ENAIRE and ITG are working on that project. So I feel a bit more comfortable talking about it. And at the end, in AMULET, what we want is to test different U-space architectures, also validating different use cases and the coordination between these use cases. The important thing here is we will try to fly over 100 hours, combining all these operations in 3 different scenarios. In Spain, Santiago de Compostela, in the Netherlands, Amsterdam, and in the UK, in Cronfield. And all the conclusions that we have, all the recommendations will help to build the future U-space environment. And just to continue, just to close my section, promise that the last bullet is just to introduce the presentation of my colleague, Daniel Gutierrez, because at the end, all these challenges, all these operational challenges will be linked to safety challenges that are also very, very important, because at the end, safety always first. So thank you, and the floor is yours, Daniel.
Thank you, Enrique. Okay, yeah, I will continue from that point. Now I'm going to introduce the safety challenges that U-space will have to face in urban air mobility and urban scenarios. We are going to introduce first the the problems, the main problems that we have identified, and the main problems that we are facing. We're preparing deployments of geospace services in these scenarios to prepare demonstrations and so on. And then after introducing these safety challenges, we are going to take an overview about how these challenges are being faced today by the industry and by the different stakeholders. And we will take a look in the different safety assessment methodologies that are being used at this moment. We will propose different approaches to overcome these safety challenges. And in the end, I hope that we all have an overview of these safety challenges and the future work that is going to be carried out in the near future. So, as I said, I'm going to start identifying the different or the main important safety challenges that we have identified. Most of them are linked to the operational challenges that Enrique has explained before, but some other are related to the fact that geospace is at a really early stage in this moment. Geospace is a new technology, and it means that we haven't up to this moment massive deployments of geospace technology in the ground. So we do not have an historical service record of data, of operational data. We do not have safety metrics either. These two points are challenges because this information is needed to be able to perform safety assessment methodologies that are useful to guarantee the safety in operations. And this is also another challenge that we have identified. At this moment, we have safety assessment methodologies specific for geospace. We have Medusa, which we will explain a little bit further later. And we will have the Appendix H in SORA, which will tackle the UTM aspect related to risk assessment, but it is still to be published. So these methodologies are still under development. We can say that they're still to be tuned. So next slide, please. And as I said before, some of the challenges are related to the current stage of the technology, but some other are related to the operational challenges that my colleague Enrique explained before. We're going to have really high traffic density, much higher than we are used to in similar scenario up to this moment. We're going to fly and to operate in urban scenarios where drones and aircrafts are going to fly at least at some point in operation near ground and around obstacles. This imposed another safety challenges because we need to structure the airspace and the operations in these urban scenarios to guarantee that these operations are safe and are efficient. We're going to have high traffic density, so current technologies maybe fall short to manage to cope with this high amount of data, and we will need to use new technologies such as big data, or we will have to replace the current approach where we have voice communications by digital communications. These are new technologies, these are new approaches that do not have a history record, and we will have to analyze and to assess the safety implications and extract the safety requirements for these new technologies and assure the safety. And finally, the geospace is a data-centric technology. For the geospace to work properly, it will be needed to have a reliable source of data. We will need to have reliable databases of obstacles in this urban scenario because we are going to fly near near them. We are going to fly near the ground. So this is another safety challenge. We need to tackle properly how we produce and how we manage this data so that it is reliable. Okay, and these are the 6 main safety challenges that we have identified, and we wanted to introduce in this webinar. Next slide, please. The previous one. Okay, so before my colleagues have talked about the different projects that are now being funding and developing by different entities. I would like to highlight the work that CESAR Joint Undertaking is doing by funding exploratory research and very large scale demonstration projects, which aim to define, develop, and deploy the technology needed to build these U-space services. These projects are aimed to contribute to close the gap that we have identified before. This operational, this need for more operational insights and insights about how to organize the traffic operation, how to structure the airspace, and how to and finally how to test them in a realistic scenario. And here is where we are working in AMOLED, as my colleague Enrique said before, to test U-space technologies for urban air mobility use case. Okay, next slide, please. One especially important project within CESAR was CHORUS. CHORUS was a project aimed to produce the concept of operations of the U-space, and one of the documents and the information that CHORUS generated was MEDUSA. MEDUSA is the first specific safety assessment specific for U-space. MEDUSA means methodology for U-space safety assessment, and it is based on CESAR safety reference material, and it is based also in SORA for the risk analysis of drone operations. In this sense, MEDUSA might be considered as an evolution of SORA, as it combines the outcomes of several SORA analyses that takes into account the point of view not only of the operator, but the point of view of other stakeholders, such as the traffic management, for instance, to have an holistic evaluation of the operation that tries to ensure a better approach in safety management, in safety assessment. In this sense, MEDUSA covers part of the gaps that have been identified previously in SORA. Next slide, please. However, well, MEDUSA is a fairly new methodology. It is not still spread in the field. There is no well-known methodology at this point. And in this urban scenario that we are focusing today, there are some challenges that maybe MEDUSA is not prepared to cover yet, which are specifically the high density traffic expected in urban scenario. And in addition, MEDUSA defines safety objectives whose means of compliance are still to be published. And well, this is important, especially because in urban air mobility, we are going to have drones under the certified category, and we are going to have also aircrafts even. Next slide, please. Okay, so what can we do to have an approach to safety assessment in this scenario, in U.S. for in urban scenario? Well, we can take a look to what it is done right now in U.S. space. In U.S. The U.S. standardization and regulation effort is aligned to U.S. space, although it is some years in advance because it started a little bit earlier. So we can take a look to the approach that is being followed with U.S. And to assume what we can do later with U-space in urban scenarios. Next slide, please. Okay. We all know the European regulation, which came into force this year. It proposed to classify the drones in 3 categories. This is at this point really well known. We have the 3 categories proportional to the risk. Drones are classified in different categories according to the risk level. We have 3 different risk levels. Sorry, we have the open category with the less risk. We have the certified category with which is the one where we have drones carrying passengers or drones flying over people, and in between we have the specific category. For the specific category, we have a specific safety assessment or risk assessment methodology called SORA, which was developed for this. SORA analyzed the risk from an operational point of view, taking into account the risk at ground and on air, and in the end, it produces it classifies the operational within 6 different levels, which are sales, the different software utility levels, and it also defines safety objectives, which are proportional to risk. These operational safety objectives, in short, also, are defined for 3 different risk robustness levels: low, medium, and high. The means of compliance for this also at this moment are under development. Some of them have already been published, but well, most of them are still under development. And there is a lot of work to be done, especially for the medium and high robustness levels. However, if we took a look to what is done with also
B is with also approve and full support the proposal for the technical.
Daniel, sorry, but we cannot hear you. I think you are mute.
Related to safety, where which have already published some of their the same approach for aviation. Okay, so it starts with a collapse analysis, and then at least for the medium level, it continues with a functional hazard analysis, and continues with faulty analysis and in a traditional safety assessment approach. Next slide, please. But I have already said that there is a lot of work to be done regarding the publishing the means of compliance for the different OSOs within the specific category. But in the certified category, which it's important in this scenario because air taxis, cargo drones flying over people are going to fall under this category. Well, the current stage in these categories even earlier. The certification specification for US is still to be published. However, well, we can speculate that the means of compliance for this is going to be aligned at least with the current standards in aviation, such as DO 178 for software and DO 254 for hardware. Okay, next slide, please. Okay, so we have seen that in the US domain, we have safety assessment based on SORA, which define safety objectives that impose different that can be fulfilled through different means of compliance. And we have seen that this approach has been aligned to a standard or to traditional manned aviation. Okay, so we can safely assume that in geospace we are going to follow the same path. So it is worth to take a look to what it is done in traditional ATM at this moment. In ATM, we have the safety management system, which is a systematic approach that defines activities, activities that have to be done by organizations in order to achieve an acceptable level of safety. In Europe, this is regulated by the European Regulation 1035, which is derived from SR3. SR3 defines SMS as a framework of 4 components that takes into account safety policy, safety achievement, safety assurance, and safety promotion. Next slide, please. Okay, I have just talked about SR. SR are the Eurocontrol safety regulatory requirements that provides advice and support for safety in ATM. There are 6 of them, but the 3 more related to U-space are SR3, SR4, and SR6. SR3, named the use of safety management system by ATM service provider, is top level. SR4, risk assessment and mitigation in ATM, concerns about the use of risk assessment and mitigation measures, including hazard identification in ATM. The means of compliance, one of the means of compliance for SR4 is the Eurocontrol the safety assessment manual, which follows a similar approach to the one that we have just seen. It starts with the CONOPS, with the concept of operations, to later produce a functional hazard analysis, continuing by safety assessment in order to identify risk and allocate them. And then we have SR6, which expands SR4 in regard to the implementation of software assurance. One of the means of compliance for SR6 is ED, Euroguide ED 153. Next slide, please. Which for next slide. Okay, which for those of you who are not familiar with this standard, it basically allocates SWAL, software assurance level, to different software components according to the severity of their failure, their associated failure conditions, and the likelihood of these failures or these effects to happen. It defines 4 different SWAL levels, from 1 with the most critical to 4, the less critical, which can be compared to maybe more known, better well-known aeronautical standards such as the DO 178. Next slide, please. So if we take all of this into account, what we have is that maybe a visual approach to tackle safety assessment and safety assurance in geospace in the future, maybe to starting with describing the geospace architecture and the operational, the concept of operations, then continuing with safety or risk assessment based on Medusa and Sora to identify safety objectives. And from here, as in the same way as it is being proposed in the US domain, follow a safety assessment and assurance process aligned to what it is done currently within SR. This process would start with CONOPS, then functional hazard analysis, followed by safety assessment, and then check the fulfillment of safety objectives that could be shown by the application of standards such as the ED 153. It is important that this safety approach is introduced in geospace since the very beginning, as at least in urban scenarios, we are going to manage things flying over people and in some cases, carrying people. Okay, next slide, please. Okay, and finally, this is my last slide. We have said during the presentation that U-space services are going to be digitalized and they are going to be massive. They are going to imply many different types of aircrafts. So, in order to provide these digitalized services based on digital communications, data is really important. Data is safety critical in this scenario. Again, how data is managed within traditional ATM safety approach, where we have the concept of aeronautical data quality, which is tackled by European ED 76, or called by TCA as DO 200. This standard provides requirements about how to process aeronautical data. And considering aeronautical data, this data used for navigation, flight planning, terrain and obstacle awareness, flight deck displays, flight simulators, and others. This standard provides guidance about how to develop, change, implement, and process aeronautical data, so that we can guarantee that data is reliable, and that by processing data in the different services, we are not introducing errors. And another important point within ED 76 is that in constant, differently to what happens with software, which is meant to be static, aeronautical data changes over time. So ED 76 takes into account this, defining how aeronautical data can be updated in what is called ADAC cycles of 28 days. Again, as I said before, aeronautical data is safety critical for these services, especially for in geospatial scenarios, in urban air mobility scenario, given that geospace is data-centric. So again, since we think that at the very beginning, it is really necessary to have this safety approach also for the generation and management of data in this scenario. And this is all from my side. Thank you.
Well, thank you very much, Daniel and Raquel and Eduardo. I think now is the moment that all of you have been waiting, because I think we have several questions in the chat. And maybe the rest of the presenter can turn on the camera so we can proceed. I will be reading the questions and try to allocate the question to the best presenter at this point. So the first one is from Julia Sanchez, who said that ATN is a system and U-space is a concept. How do you foresee the integration of U-space into ATN and the interoperability of the U-space services with ATN? I think this question might be for ENAIRE, because at the end they are talking about the interface between ATN and ATN and the U-space. So Raquel, Eduardo, any one of you can answer that?
Yes, well, that's not a short answer, let's say. Well, at the beginning, here it depends also in the frame time where you are what you are visioning. At the beginning, of course, the interface, it will be to share knowledge between, let's say, the two worlds, just to seek the integration. And then as time goes by, so it's quite feasible that at the end it's only just one system managing everything. But this, it will be in the future. the long time, in a lot of years, not in the years to come in the short place.
Yeah, I agree. Actually, if I may complement, I think this is a very good point that you say. It will be delivered in the next decade, maybe. And right now we are researching, we are doing research and see different demonstration to see how we can integrate ATM and U-space for a safe and efficient operation. For example, later this year, you can see several papers and several documents coming from the different research project that I mentioned before, called AMULET, U-space for UAM, where we will try to address all these issues to set up the roadmap for this delivery. Because at the end, it's clear that right now, as I said before, ATM is working on a different with different systems, with a different approach. So we need to bring these two worlds together to find a solution. But I think it's a very, very good question.
If I may, I would also like to comment. U-space is now maybe it is now a concept, but it will evaluate. It will evolve to a service. Somewhat, it is already a basic service or system. If you can consider this, and this service, this system is going to evolve during the coming years. But regarding to the ATM U-space interface that was asked in the question, I think that the CIS is going to be really important as a focal point of contact in at least in the centralized approach of U-space and the CIS.
Okay, thank you, Daniel. So it's a very interesting point. I think we can go to the next question because I think we have a couple of them coming. So the next question was already responded. Thank you, Andrew, for providing the link. It was where can we find the Medusa document? You can see at the chat that Andrew Headley is waiting for name. Has provided the link where you can find the document. Thank you very much, Andrew, for helping me with that. And then we can go with Danai Riesgo, which department will be in charge of the new operations related to the urban air mobility? Will the airport be responsible for the control of these operations? Nowadays, operation technicians are responsible for flow controls. Operation technician, thank you. I think this is a very good question, and maybe I can try to address it personally. Maybe you can complement from ENAIRE. Because at the end, I think it will depend on the first on the city and then on the ANSP managing the area. For example, if there is no ANSP managing, for example, if there is a CTR in a city, there will be then the control may be done, or part of the control may be done by the airport. However, if there is no airport close to the city where this is going to be deployed, it will be another department who manages this or another company. So I think it's quite important there to differentiate the different cases of cities and not try to apply a one-size-fits-all approach to all to the department allocation. Don't know anyone want to complement this?
No, Enrique, I think you have addressed it quite well. I think it's something that it's yet been defined in the UAM projects, different ones, and also, yeah, the cities, big cities are usually very affected by CTRs. So at the end, yes, for sure, we will have to coordinate with the ATS providers providing services in the CTR.
Yeah, perfect. No, I fully agree with that. I see that Walter Decker has included just a comment regarding this topic. I think is, as he knows, right now U-space will be integrated in ATM, because especially local authorities like EC and DFS are working on this. Yes, it is true. In some cases, U-space will be integrated in the ATM, and also this is related to the next question. Also, that it's outside the limit of U-space. How will drones flight will be managed? Self-separation. I think maybe this is more a safety issue. Maybe Daniel, you can jump in here.
Yeah, well, U-space is not going to be deployed all over the airspace. Yeah. So for those places where U-space is not going to be deployed, the drone operators will need to follow the process according to regulations. If it is low-risk operations, they will fall into the open category, and they will be able to fly without no further work. If they are flying in the specific category, they will need to go through the SORA process and get the approval from their civil aviation authority. And if they are carrying people or flying over people, even though the operation is not carried out over in U-space airspace, then they will need to have a certified vehicle. They will have to follow the standard procedures as well. Well, in this sense, CORUS, in its concept of operations, defines three different spaces, X, Y, and Z, where this is further developed.
I think this covers the question. So thank you very much, Daniel, for your input there. Now I think there is another one for you. It's a question regarding the safety approach diagram. How can we use SORA before defining the CONOPS? CONOPS are the first step in a SORA approach for risk class determination.
Yeah, it is right. Yeah, in the maybe the slide was a little bit misleading because in the slide first we talk about describing the U-space architecture. Here I refer to the CONOPS of the operation, but later when we went through the let's say SR aligned safety assessment, we talk about CONOPS of that specific issue, of that specific safety objective.
Okay, perfect. Then we have another two questions right now. The first one is for Andrew Hitley, with no name. And it says, what are the most significant blocking items to deploying UAM? Technology, standardization, regulation, flight rules, technical, public acceptance, something else? Well, actually, as I prepared the operational challenges, I can say this is not going to be a very specific answer, but at the end, it's all of them. Because right now we are on an early stage. So right now the blocking points are from one side technology, because for example, the air taxis are not ready to fly yet, or because not the U-space services are not developed. So you cannot integrate that into the cities. But also it's a problem maybe of standardization. It's not so much, but maybe regulation, because at the end, yes, we have the basic regulation right now, but we need the agencies and we need the different guidelines to be able to develop all the systems, all the services, and to define the airspace. But also, I think one is quite important is not only about that, is how the airspace will be structured. As I said in my presentation right now, US community is exploring different ways to address the airspace configuration. And I think this can be interesting because at the end, the three topics that I mentioned, first technology, regulation, and how the airspace will be structured are going to be key for deploying UAM in the cities. And if I have to say something else, I said that beyond of that, we always need to keep an eye on public acceptance, because if at the end public doesn't want that UAM is deployed, we are not going to see UAM in our cities. But just one more comment. Right now, in the process, I think also it's very important to test all this technology, all these operation, all these flight procedures, to test everything first in simulations. This is one of the approaches that we are proposing, because at the end, we need to have data to be able to analyze and to provide proper results. But also, after that, we need to go and test in real life the operations and all these concepts. And for that, it's very important to have a sandbox, to have a proper test site, to be able to do these real time and real operations in a safe space where we don't interfere with the rest of the operation. And in our case, for example, in ATM-What, we are proposing this approach, and before the real time, we will try to address the concept using simulations first, and later to try to do the test in several test sites. For example, the one that ITG has prepared in Ancora, in the northwest of Spain. Don't know if I address your question, Andrew. If not, we can continue later in private. Let's go to the next one. Do you see U-space integrated into ATM or rather segregated from to ATM? And I think this one can be for ENAIRE.
Yes, I can get that question. Well, at the beginning, let's say it can be segregated, but as I said before, in the answer to Julia Sanchez, the vision is to be just one in the long time. So the beginning, small segregation, interfacing, and then just working through the line of integration.
Okay, perfect. Maybe Danny, if you want to complement something, because at the end this may be considered part of safety, because depending on the environment, you can do one thing or another.
Yeah, I would say that at the beginning, they are going to be segregated. I don't know what is going to happen in the future, but I think that as SWIM and other technology deployed and spread all over, maybe we see a further integration between different services.
Okay. Brilliant. Then let's go, because the time is running. I think we are out of schedule. We have two more questions, and then we will close the section. First is from Alberto. What are the requirements to get a 425 kilos drone certified to fly in U-space? I'd appreciate a link and document. So I think this one is for you, Daniel, and of course we will try to provide you the link document for the information that you are asking, Alberto. And we will try to address this together with them when we send the video and the slides.
Okay, the certification and specification for drones are still to be published. However, we can refer to existing special conditions and other information from JALUS, such as the CS like UAS and some others. If you refer, when you talk about hardware, if you refer to electronics, then they should be developed according to DO 254. But I'm talking about the drone itself. I mean, it doesn't matter if the drone, if you're flying under U-space or not. If the drone is certified, if the drone operation falls into the certified category, then the drone will have to be certified. Will have to be certified, no matter where it flies. Okay. If you need further information, Later, we're going to provide an email for contact. You can contact me there and discuss it more in detail.
Yeah, I think that's a good idea because at the end we are now 3 minutes over time. So Alberto will try to address this privately, okay? Because I think you are asking about structural requirements, so we will go further there. And then the last question that we will have time to address online, but please feel free to send the information to us later. Or the additional question is, do all ANSPs and ATCOs are willing to integrate managed U-space? If not, from your point of view, which kind of organization will be willing to take the responsibility? And I think this is clearly for ENAIRE.
Okay, I can take this one. I don't know if willing will be the correct verb, but the fact is that drones are already flying there. And we could see it in the figure presented by Eduardo, how the growth in the drones flight is increasing very rapidly. And also many of them, and the majority of them, are flying controlled aerospace. So this is something that is affecting ANSPs and ETCOs. And of course, I think U-space will enable this integration and will make the life for ETCOs easier, at least in U-space, aerospace. So I think it's beneficial. In the case of Spain, which is the one I know, we are working to deploy U-space in Spain. And as I explained, we advocate for the centralized architecture, and where maybe ENAIRE could take the place of the Common Information Service provider. And I think in the whole Europe, all ANSPs are working on this very hard.
Okay, thank you very much, Raquel. I think this addresses the question. We can further explain later. And well, I think we don't have more time for the question. We would love to be here with you to continue talking, but maybe we have the opportunity in the future, because at the end, our idea is to continue these sessions from the Galician Institute of Technology to bring closer to all of you the urban air mobility and U-space concept. So please don't hesitate to contact us in the following email address, uas@itg.es. We will be more than happy to receive your feedback about the meeting and additional questions. And in the coming days, we will try, maybe next week, to provide the slides together with the video and a summary of the questions and answers. So thank you very much for attending the meeting. I hope you have enjoyed, and stay safe, and see you soon. Thank you.
Thank you. Bye.
Thank you.
Thank you.
Bye.
Thank you. Bye.
Bye-bye.
Bye. Thank you. Bye. Thank you. Bye.
Thank you. Bye.
Thank you. Bye-bye.
Thank you very much. Goodbye.
Thank you. Bye-bye.
Bye-bye.
Thank you.
Bye bye, muchas gracias. Hasta luego, buen puente.
Igualmente, muchas gracias.